Representing the mathematical idea of a part of a whole with fractions has several challenges. The challenges are primarily the shift from whole numbers to rational numbers and students moving from an additive world to a multiplicative world. The first challenge of a shifting number system emerges as students begin to work with increasingly complex number systems as depicted here in Figure 1. Typically in early childhood, students count with natural numbers. That is typically 0, 1, 2, 3, etc. These are also referred to as positive whole numbers. Later, students work with integers, which includes the negative numbers. Following their work with the integers, students start to work with rational numbers and fractions in grade 3. Rational numbers being numbers which can be denoted by the form a over b, where a and b are an integer and b is not 0. The second challenge is students moving from an additive world to a multiplicative world. Students deal with questions of how much more, how much less, how much longer, etc., all dealing with adding to or subtracting from an existing amount. As students shift to work with whole numbers to rational numbers, they move from things that they can count, discrete quantities, to things that they can measure, such as length, area, or time. The challenge which manifests in fractions is the use of additive thinking. That is, 1/4 is greater than 1/3 because 4 is greater than 3. Or 0.157 is greater than 0.63 because 157 is greater than 63. By making fractions real and showing applied use of the fractions to overcome a challenge the students grapple with in their lives, the students will see value in their learning. This is best done by first visually representing fractions with area models. In this example, we want to add these two fractions. We can visually represent the two fractions with two rectangles which depict the fractions 1/3 and 1/4. We can add these two fractions together by overlaying the two rectangles in a common denominator, or to get a common denominator, shown here. The final step is to create a new rectangle and divide it into 12ths. The two rectangles can be added together and then the new rectangle shaded with the total. So let's make this real by making the rectangle a pan of brownies. This pan of brownies needs to be divided amongst 12 students. By applying the math to a real-world challenge, we can engage and motivate the students from an undivided pan of brownies to a divided pan. Thanks for watching.